Now, a square pyramid of 35 mm sides of base and 60 mm axis length rests on HP on one of its corners of the base such that the two base edges containing the corner on which it rests make equal inclinations with HP. Draw the projections of the pyramid when the axis of the pyramid is inclined to HP at 40 degrees and appears to be inclined to VP at 45 degrees. So since a square pyramid of 35 mm sides of base and 60 mm axis length rests on HP, so obviously we have to start from HP, that is from the horizontal plane. So since it is one of its corners, so the end point should be a corner. So A dash is a corner and also C dash is a corner. You place the square pyramid in such a manner that A and C will going to be the extreme points. So here if you keep it vertically, so A, B, C, D, you have the corner position. So here, since all the base edges, that is AB, BC, CD and DA, all the base corners are resting on HP. So obviously that means it is parallel to HP. Since it is parallel to HP, so I am getting the true shape in HP. That is the true length in HP. So we will go to each side, we are going to have 35 mm side. So then join the diagonals AB, AC and BD. So it will go to meet at the center, which will go to the point 001. So when you look from the front view, we can see the height. So the height will going to be seen in the front view, which is of 60 mm length. So that is seen in the vertical plane. So we have the axis, which is 60 mm. So here, once you look from the front view, ABC is near to the observer, so A dash, B dash, C dash is visible, and D is away from the observer and it is coinciding with the point B, so D dash becomes invisible. So when you look from the front view, O dash is at the top, so O dash will be at this point. So since OA is joined, OB is joined, OC is joined and OD is joined, so here O dash is a visible point, A dash is a visible point, so visible to visible is visible, so you dark this. Similarly, O dash to B dash and O dash to C dash apply the same thing. So you are going to get this is a dark line and this is also a dark line. Then when you look from the front view, AB and BC are the two visible edges. So A dash is a visible point, B dash is a visible point. So visible to visible is visible. So AB, A dash, B dash is visible. And similarly, B dash, C dash is also visible. So when you look from the top view, ABCD is visible, so ABCD is visible and you have got the apex point. So draw continuous dark line between AC and BD because OA is a dark slant edge and OC is also one of the slant edge. So here OA and OC, similarly OD and OB. So you are going to have four slant edges and here you have the triangular face OAB, OBC, OCD and ODA. So coming back to here on the orthographic view, so we have to write a square of 35 mm side. So consider any point here, since it makes equal inclinations. So from here you measure an angle of 45 degree with respect to this vertical and you measure an angle of 45 degree with respect to this vertical and then draw an inclined line here and here. Then with this as center, take a radius of 35 mm, cut an arc on this side and also cut an arc on this side to get this point B and D. From this point as center, take a radius of 35 and then cut an arc on this and also from D you cut an arc to cut a previous arc to get the point C. Then dark these lines, that is AB, BC, CD and DA, and then complete the diagonal AC and BD with a continuous dark line. Then you then you project all these points to the front view, then draw a vertical projector from A, B, D and C to the XY line to get this point A dash, B dash, C dash and bracket D dash and O1 dash here. Because when you look from the front view, ABC is near to the observer, so these 3 points are visible, and D is away from the observer, so it becomes invisible. So when you look from the front view, the height can be seen from O1 dash, you measure a height of 60 mm axis length. So you measure 60 mm and mark this point as O dash. Then join O dash to A dash, O dash to B dash, O dash to C dash with a dark line. Then dark between A dash to B dash and B dash to C dash to complete this. Now since the axis is parallel to VP, so I am getting the true length of the axis O dash, O1 dash. Now he says the axis is inclined to HP at 40 degrees. Since the axis is inclined at 40 degrees to HP, now you can see here in the second position. So here, Since it is resting on one of its corners, the A dash is the corner which is resting on HP. Either you can resist on A dash or we can resist on C dash. If you resist on C dash, then you have to rotate clockwise. If you resist on A dash, then you have to rotate in anti-clockwise. So that means it is rotated to the left side. So here, since the axis is inclined to HP at 40 degrees, so the base has to incline at 50 degrees. So consider any point at a convenient distance between C dash to A dash, and then from here you measure by using the protractor, you measure an angle of 50 degree and then draw an inclined line. Then measure the length from A dash to C dash. From A dash you cut an arc on this to get this point C dash. Similarly, you measure the length from A dash to B dash. From A dash you cut an arc by using the compass to get this point B dash D dash, and also you mark that O1 dash. Then from here O dash O1 dash is perpendicular to A dash C dash. So from O1 dash you measure an angle of 90 degree by using the protractor with respect to AC. Then draw a perpendicular line here. Then by using the compass you measure the distance from O1 dash to O dash, which is equal to 60 mm. From here you cut an arc and complete the view, which has been exactly the same as that of the first position front view. So now we have to write the top view. Since we have to write the top view, so draw a vertical projector from O dash and draw a horizontal projector from O to get this point O, and draw a vertical projector from A dash and draw a horizontal projector from A to get this point A. Draw a vertical projector from B dash, D dash and O1 dash, and draw a vertical projector from D, horizontal projector from D to get this point D, and draw a horizontal projector from O1 to get this point O1, and similarly draw a horizontal projector from B to get this point B here. And now draw a vertical projector from C dash and draw a horizontal projector from C to get this point C. Once you get these points, then join them with a continuous thin line. Join between A to B, B to C, C to D and D to A, and then join O to A and O to C, and then join O to B and O to D. Now we need to write the visibility and invisibility. All these things which you should do by using the continuous thin line. Then, so first rule of the condition of visibility is all the exterior edges of the boundaries of the solids are visible. So OB, BC, CD and DO all are on the boundary of the solid. So naturally that will become visible. So you dark this. Then when you look from the top view, O dash C dash is near to the observer. This is also quite evident from here also. OC is the one which is near to the observer when you look from the top view. So you dark this OC line. Once you dark this, since the edge or a corner which is on XY line in the front view is always invisible in the top view. So that means A will going to become invisible. Once A becomes invisible, so from A we have three edges. One it is AB, other one is AD and the other one is OA. So since A is invisible, so naturally OA becomes invisible, but OC is the visible which is exactly coincide with this. So because this is quite evident here, OC and OA both are on the same line, on the same plane. Since OC is visible in the top view, so naturally OC will be dark and OA, which is the hidden edge, but we cannot show the hidden edge because the priority has to be given for the visible edge. So OA will not be shown. Since OA is invisible, so naturally AB and AD will also becomes invisible. Since the portion of AB and AD becomes invisible in a square of AB, in a rhombus of ABCD, so naturally O1 will going to become invisible.